What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. Thank you, everyone, for joining. And today is a special day because we're on the last week of our J.E.D.I Digital SAT Masterclass program, week 4 of 4. And today is a fun day, my favorite day, to be honest, because we are taking student questions. So everybody posted on the J.E.D.I platform, which you guys can join in the description link below. Actually, let me show you what I'm talking about so you can see. So if you guys haven't joined this class yet, this is where all the action's going down. We have over 500 members, so cool. And people posted questions that they wanted to answer today. So I posted them up here, and we're going to go through them one by one. I had to remove a couple that I wasn't sure where they came from. So again, we're doing questions that are publicly available, obviously, through the College Board website or Khan Academy, things like that. And some of them I wasn't sure where they were coming from, and I wanted to, limit it to the ones that I'm allowed to show. So that's why some of them you may not see if you did post them, but that's why I didn't include them. But anyways, we're going to jump through. I'm also going to answer questions. What's up, Cole? And what's up, Nair? I'm going to answer questions as well in the chat. So if you guys do have questions, make sure to post them as well on top of the ones that you're seeing here. And if we could start off, just let me know where you guys are from, where you guys are taking the SAT this weekend. I am taking it as well, so that's going to be really fun, and I can't wait to do that. Okay, here we go. We're going to start with this nice quadratic. And let's check it out. X squared plus bx plus c equals 0. In the given equation, b and c are constants. Negative b plus this equals 18, and this equals 10. What is one possible value of x? Okay, that's a very interesting problem. Let's check it out. So let's see here. Negative b. Oh, okay. So check this out. Obviously, they're using the quadratic formula. So this is the way that I'm going to approach this. I'm going to say, in this one, the solution to this is negative b plus or minus square. And actually, let's say take just the plus side, because that's what we're seeing over here, equals 18. Negative b plus square root of b squared minus 4a, which is 1, that's why it's not here, times c over 2a, which is 2. Okay, actually, no, let's not even do that, which is equal to 18. Now, what we can tell from this, okay, since normally this is over 2, right? Or 2a, I should say. But they're saying with that denominator, which should have been 2, was multiplied over here. That means if I divide the side by 2, divide both sides by 2, I get 9 here, and I get 2 here. Now we've got a actual solution for the quadratic formula, meaning this is a solution of x, okay? Likewise, we could do the same thing, but they said one possible value of x, but we just solved it. But the other way we could do it is we could utilize this one and probably give us a different solution. Let's try it. So negative b minus the square root of b squared, again, minus 4ac, a is 1, so that's just c, is equal to 10. Again, I know that 2a, because a is 1, is 2, so if I divide both sides by 2, now I come back to my second solution of 5. And so either of these solutions would be legitimate. You could enter either 9 or 5, and that's how you do it. Hope that made sense, guys. Let me know why multiply 18 by 2. See, I think you have it backwards. I think it's the other way. I think you need to, Jackie says you need to multiply 18 by 2. I think we need to divide 18 by 2, right? Because they took the quadratic formula and what do you guys think? Let me know your thoughts. Yeah, Cole says, interesting. Nair says, I'm going to skip the reading because I took IELTS last year. Yeah, but that's how I think you do it. I don't have an answer key for this one, but that's how I would do it. I believe the answer 9 should work, or 5. Okay, now we got this one. Let's check it out. It says the given system of equations where c is a constant has exactly one solution. What is the value of c? All right, we've seen a lot of problems like this from the practice materials. Let's check it out. So one solution. Now, I'm going to show you how to do this in Desmos as well, but I want to make sure you guys are comfortable doing this by hand, which I think this one, yeah, I would do this by hand. So first, we're going to solve a system, we're going to set them equal to each other, right? And then, since I know it's a quadratic because the highest degree is 2, now I'm going to set everything equal to 0. So we're going to minus 12x, we're going to minus 18, and set it equal to 0. Now, they're talking about nature of the solutions. That's exactly one solution. What does that remind you of, or what should that remind you of? Anybody, Cole? Let's put it in here. When they're talking about the nature of the solutions for a quadratic, what should immediately come to your mind? I see Jackie says substitute y into the equation to make a quadratic equation. Maybe are you talking about the other? I'm not sure if you're talking about this problem or the other problem. But not what I was thinking of, per se. Cole, do you have any thoughts? Callum, any ideas? Okay. I'm not seeing anything posting up in the... Oh, discriminant from Fran. Yes, there we go. Franco says discriminant. That's what we need to think of. You need to train your mind this week. Nature of the solutions. One solution, no solutions, two solutions. Discriminant, okay? So we're going to go straight to the discriminant, which is b squared, which is 144, minus 4a, which is an invisible 1. And my c is not just c and not just negative 18. It's the entire constant. Minus 4a, which is 1, and then c, which is c minus 18. And if we have exactly one solution, that's when the discriminant equals 0. And Cole says it should equal 0. Let's go. Good job, Cole. Cole's killing it. Okay. So now we got a beautiful equation. Now we just solve, right? Distribute negative 4. 144 minus 4c. Negative 4 times negative 18 is plus 72 is equal to 0. 144 plus 72 would give us, what is that, 216, right? 216 minus 4c equals 0. Add 4c to the other side. 216 equals 4c. And divide by 4. And there we go. We get our value of c. I'm going to do this mentally. Divide by 4. I like to take half-half. So half of 216 is 108. Half of 108 is 54 for the win. Boom, done. All right, guys. Hope that made sense. Okay. But these, I said I was going to show you how to do this on Desmos too. Again, I think that was easier than Desmos. But if you want to see the way we would do it in Desmos, let's go. So I'm going to put in the two equations. Y equals x squared plus c. And c, we need a slider. And then over here, we have y equals 12x plus 18. Okay. All right, so check it out. We got the two lines. We need to adjust c so that we have one solution. But let's see if we can move it around, right? See, this is the type of problem where it's kind of difficult to use Desmos because like we get to 10 and then you're like, well, how big do I have to go, right? So we'll set this up to go to like 100 or something. This is kind of knowing what's, how we're going to get there, to be honest. But, yeah, this is what you'd have to do, and you have to keep moving it. I mean, look, this is not a great use of time, in my opinion. Now we go to 64. We go past it. Now we have to dial it back until we get one exact intersection. Because I know it's 54. I'll take it right to 54. And there we go. There's that 1 point of intersection. You be the judge. I personally like doing this one by hand, but yeah, it's up to you. And again, I think it's going to really serve you well to always be thinking like, how can I do this by hand or how can I do these types of problems by hand? Because I'm making a predictions video that's going to go out later this week, but I truly do think that the College Board is going to spice up these questions in ways where it's not so easy to just plug and chug into Desmos like this one. Like they're going to have more constants, more coefficients, and unknowns and whatnot. All right, Cole, we will see you back. All right, 15, here we go. We got this one. All right, it says a rocket is intended to be launched straight up, is instead launched at an angle of 10 degrees shy of vertical as shown. If the rocket travels 10,000 meters in a straight line, approximately how far to the nearest meter has it traveled? Okay, so this is a nice little trig question, and we're trying to find this distance here, right? They probably won't even give this anymore because you have a calculator throughout, the entire test. But anyways, this is a straight trig problem. Now, when you're solving something like this, the way that I like to approach these problems is think of a trig function that is going to involve this angle, the side we're trying to solve for, and this side that's given to us. Okay, so this needs to be that there should be a right angle there, but that is a right angle, right? We know that it's going straight up, and boom. We know that's got to come straight across a straight line. Actually, this problem's a little flawed. It should say that it's perpendicular, I think. But anyways, so what is going to use this angle, the opposite side, and the hypotenuse? That sounds like sine, right? So that's my first objective. Just find the right trig function that uses all those parts. And we say sine of that given angle 10 is equal to opposite, which is unknown, over my hypotenuse, which is 10,000, right? And now we have an equation. Now all we got to do is multiply across and we can solve for x. So it's 10,000 sine of 10. If you do this in Desmos, again, they gave us those values. I don't think they're going to do that actually on this SAT because we have full access to a calculator the entire time. But anyways, we use Desmos. Make sure you're in degrees, and we've got 10,000 times sine of 10, and there's our answer, 1736. Let me just make sure I didn't make a mistake with anything. 10,000 times sine of 10. Yeah, 1736.5, and that's it. 1737, because they said to the nearest meter. That's how you do it. All right. Let me know if that made sense. What's up from Lebanon? So cool. What's up, Ibrahim? How do you know it will be a right angle? Yeah, I would say this question, to be honest, is a little flawed. Now, I can assume it has to be a right angle, otherwise the question is impossible to solve. But it says it's going straight up, and then it's saying that the rocket travels in a, well, no, that part's a straight line. I guess I'm just kind of assuming because we're looking at this like straight across, right? We're looking at that exact horizontal distance, excuse me. So if we're looking at the straight up path, looking straight up in the horizontal, it should form a right angle. But you should get more specific detail on an actual real SAT problem. And if you don't, and the only way to solve it is you have to make that assumption, you got to make that assumption. But the College Board's good like that. All right, this one. Of 1,500 households with only cats and or dogs, 40% of cats, 60% of those households have only one cat. Okay. 50% of the households have dogs, and 80% of those households have only one dog. 10% of the households have, again, wow, a lot of stuff here. Okay, let's see if we can break this out. So 1,500 with only cats and or dogs. So 40% of 1,500 have cats only. 40% of 1,500 is 600. I'm just doing some mental math. Okay, so 600 have cats, and 60% of these, so 60% of 600, I'm just doing it mentally, but you can do it in Desmos with 0.6 times 600. Of this, 360 have one cat. Okay. Then we have 50% of the households have dogs only. Okay, so 50% have dogs only. And that is 50% of 1,500 is 750. Okay. And of those, and 80% of those have one dog. Okay, so 80% of 750, that's 0.8 times 750. Maybe could have done that mentally, but it's all right. 600. Okay, 600, one dog. And this is what I do on all these questions. By the way, I haven't seen any of these, right? You guys sent them, but I haven't looked at them yet, so I'm solving them for the first time right here. But anyways, so we have 600, one dog. This is what I do. Map it out, make it into terms that is logical and understandable to me. Then it says, okay, 10% of the households have both cats and dogs. So obviously we got the 10% in the middle, which is 150 with both. Okay, how many households own more than one pet? Okay, pretty much, okay, all we're doing is we're excluding these guys. So even this, I mean, I put it down, but it doesn't matter because if you own both, you're assumed to own more than one, right? So basically, it's everything other than the 360 and the 600 out of that 1,500. So it's 1,500 minus 960, which gives us 540. And that would be my answer for this one. Okay. Next. All right. The function f is defined by this. A, b, and c are constants. Okay, yeah, this is, I can't remember what practice this is for. This is one of the hardest questions on the test, but I'm going to show you how to knock this out. So check this out. First, I'm going to start by making a little graph here, okay? And a little graph is going to be, you might think it's a waste of time, but it's really good to get my head around the question. So we know that we've got these two great x-intercepts. Awesome. We got 7, and we've got -3, right? Okay. So we got our x-intercepts graphed. And what I want you, and by the way, they say A is greater than 1. What does that mean? It means this is opening up. So it means my vertex is probably somewhere down below, right? Moreover, anytime we know 2 points on a parabola that have like equal y values, we know that the vertex, because points on a parabola are symmetric around the axis of symmetry, and more importantly, around the vertex. Okay, so if I have 2 points that have the same y value, like these x-intercepts, I know that my vertex is exactly in the middle of -3 and 7. So what's the middle of those two? Let's add them and take the average, right? Add them and divide by 2, I mean. So Negative 3 plus 7 is 4, divided by 2 is 2. So my vertex now I know, right? My x value of the vertex is 2. So this is all very good information. Do I know the k value? No, but I know it's got to be somewhere down here, right? So here's an approximate graph of my parabola. Just approximate, okay? And all right, let's see what else. Now, oh, by the way, we're trying to figure out what a plus b is. Now, here's the dealio, right? When I know the vertex is at 2 comma something, I can actually do a lot with this, because you want to, when you're dealing with a quadratic like this, you want to go back through all your different nice little quadratic formulas, like sum of solutions, negative b over a, product of solutions, c over a, discriminant maybe. But here, an important one to remember is my vertex formula, which is negative b over 2a. So negative b over 2a is equal to my x value, my vertex, which is equal to 2. Well, that's pretty helpful, because now, if I, here, let me put this negative down here. If I multiply across, I can say that b is equal to 2 times negative 2a, which is negative 4a, which means I can substitute this in for b and get a simpler expression with one variable. That's a lot better, right? A plus negative 4a is what we're really trying to solve for, not just a plus b. Or it is a plus b, but this is an equivalent form. A plus negative 4 is negative 3a. Okay, now we have some amazing information, because it says if a is greater than 1, right? Which of the following could be a plus b, aka negative 3a? Okay, well, a is greater than 1. Well, if a was 1, negative 3 times 1 would be negative 3. But it has to be greater than 1, so I know negative 3 is out. Okay. Now, how would I get 4? Well, if I got to get 4, at a would have to be negative 4/3, but it says a is greater than 1, so it can't be a negative. Also, I'd need negative 5/3 here to get d. Can't be a negative. The only possible option here is this one. And the reason why is because then a would be 2. 2 times negative 3 is negative 6. 2 is greater than 1. Everything matches. Boom, done. Okay. Yeah, you are. Nair is asking if you're going to get an October prediction video. I'm working on it this week. Hopefully, I'll have it out by Friday at a minimum, but hopefully by Thursday, even. So I will keep you posted. All right, this is a great one, very difficult. And this is, again, about rational functions. If you haven't watched my critical concept Bible video yet, you need to watch it. Let me post it in the description right now. 1 second. All right, so we've got this video. So again, we have people are saying, okay, this is what somebody said. Look, and I just want to highlight this video, not trying to, whatever, give myself props or credit, but like, I do think it's worthwhile noting. I don't know who this person is, but if you're debating if watching this whole video is worth it, read this. The video was much more helpful than the official SAT study booklet from College Board. The book had me convinced I was somehow incompetent, but the way he, meaning me, explains these concepts made everything click for me. The time it took to watch the video and take notes on it was definitely worth it to me. Thank you so much for making this video. Seriously, you've saved me so much time, getting the material down and improving my confidence, et cetera, et cetera. Okay, thanks again. Very welcome, by the way. Parrot Suji, what a name, what a legend. But anyways, my point is, watch this video. It will clear up so many things for you guys. You might say, oh my God, 2 hours and 20 minutes is so long. Yeah, well, you can jump around if you need to, but I would recommend definitely watching it in its entirety, because I cover everything. Between this and the formulas video, I've got you covered, okay? Anyways, let's get back to this problem. So rational functions. Now, a couple of things I talk about in that video about rational functions is the first thing to remember is that, that denominator tells me where my vertical asymptote is. All these rational functions are going to have a vertical asymptote. Now, if we look at this graph, okay, it appears as though my vertical asymptote is right here. And what is a vertical asymptote? It's like my little invisible boundary or barrier, right, where it sort of seems like approaching but never really crosses. And when I look at it like this, I mean, this is really what's happening, right? It seems like it's approaching -4. How do I know that for sure? I don't know for positive. It's a bit of an assumption, but it definitely looks to be the case. And it is what the College Board intends to be the case. All right. So what does that tell me? Well, the vertical asymptote is occurring where the denominator zeroes out. So to zero out at -4, my b would have to be +4. okay? Because then you plug in -4 for x, we'd get a 0 in the denominator. It makes sense that that would be the vertical asymptote. Okay. So now the rational function f is defined by this equation. Hold on, the part. So this is f of x right here. This is this function. And then it says if g equals f of x plus 4. So what's happening? They're shifting this. When you say plus on the inside, they're shifting it to the left by 4, which means my vertical asymptote and the function would go 1, 2, 3, 4 like this. And then, hold on, this entire function, let's see if I can get it right on, would shift over as well. Hold on. 1, 2, 3, and 4, right? So this whole thing shifts over as well. And now we've got a really good position to kind of analyze this, right? So what I should see for my vertical asymptote in the denominator is x plus 8. Ooh, I see it right here. I don't see it anywhere else, and it's probably C for the win. Now, another way to verify it is, as I mentioned, we also move the main function over to the left by 4 in general. So you could also look at that and say, well, wait a minute. I see that at -5, we were getting -6. So now, moving that over for at -9, if I plug in -9 for my correct function, I should get -6. Let's see. If I plug in -9 here, -9 plus 8 is -1. 6 divided by -1 is -6. Can we get a second point to verify? Sure. Here, I plugged in -7 and it got -2. 1, 2, 3, 4. Now I should be able to plug in -11 and get -2. 6 over -11 plus 8 is -3. Oh, that does give me -2. That's another way to verify this and do this. So my point is, if you're familiar with the vertical asymptotes, amazing. If you're also familiar with function translation notation or transformation notation, also will help you. So you got multiple ways to attack this. Last but not least, obviously we have the Desmos tool where you can choose values for A and B and sort of try and match it up that way. That's another option. I feel like it's going to take a little bit more time, so having this knowledge will be really helpful. Okay. Cole says, by the way, I figured out every live stream, there's always a 10 to 15 second delay. Oh, got it. Yeah, there is a delay for sure. And I did know that, but okay. Next, this is a great question. Again, it is a quadratic, right? So we want to think of what's in our quadratic toolkit, but let's read this. So it says again, the product of the solutions given to the equations KAB. Okay. I want to know the formula for product of solutions. Put it in the chat. I'm going to give you guys more than 10 or 15 seconds because of the delay. But I want to see that formula. You guys have to have that formula memorized. Sum of solutions and product of solutions. Go. Let me see it. All right, I see Nair, C of A. This is my favorite formula. Haha, legend. You got to know it, and Nair knows it. Now, why am I going to use this? Because it says the product of the solutions. So what is it? C, right? There's my C term, the constant in the end, over A. C over 57 is, remember, always think, how do I turn this into an equation? Product of solutions, C over 57 is, oh, wait. My C is, AB. Excuse me. AB. Over 57 is K times AB. Well, guess what? Now I got an equation, right? Now this becomes very easy. If I divide both sides by AB, goodbye, that becomes a 1 on top. I just got my answer. This is a high-level problem. I believe this is number 19 on Mod 2. This is a difficult problem. I just solved it in maybe 10 seconds, knowing that shortcut, knowing that formula. So I got to tell you guys once again how huge and important knowing these formulas and fundamentals and foundations are. Don't just where I'm seeing students get tripped up is they're relying too heavily on Desmos, because you look at some of the practice tests early on, you're like, man, I can just Desmos this whole thing. Well, they're changing it in real time, in my opinion, and are really pushing for students to know these foundations and fundamentals. So if you know this, man, it's so much easier. Plot this in Desmos, even if you choose A and B and all the stuff, like to unwind the solutions and get the product and then find K, it's going to take so long. This is so easy and so nice. So there you go. All right, next. This is obviously from the College Board, we can see. So we got triangle RST. So it says angle T is a right angle. Watch how I'm starting this out. Immediately creating a right triangle. Where R and S goes is kind of arbitrary, but I'll just go like this. And then it says line L lies on RS. Wait. Point L, sorry. Point L lies on RS. One second. Point K lies on ST. I'm not sure if I'm doing this right. Oh, yeah. And line LK is parallel to RT. So I kind of drew it, luckily, the way they wanted. And if it's parallel, those are both right angles, right? So we'll mark that as parallel. If length of RT is 72 units, length of LK is 24 units, and the area of triangle RST, the big dog, is 792, what is the length of KT? Okay, so we got a lot of really good information. What do we have here? That's what we want to think about first. I see two right angles. I see parallel lines. I see these angles are corresponding. And I also see them sharing this angle. But that's more than enough. With two angles being equivalent or congruent in two triangles, we know the triangles are similar, meaning proportionate. Okay? So we can use that information and create a proportion and solve for our missing side, which is KT, which is right here. All right? Let me do a little color coding so you can see this a little bit better. So that's KT. All right? We've got 24 is this side right here. And we've got 72 is this side right here. All right. Now, it says the area is 792 of RST. How can we use that information? Well, I know that base times height, meaning the two sides that form a right angle, and divided by 2 is going to give me that area, meaning 72 times an unknown, I'll call it y, divided by 2 is equal to my area, which is right here, 792. This is going to be great to solve for y here. So, well, let's do 72 divided by 2, which is 36y, is equal to 792. Divide both sides by 36. Let me see if I can do this in my head. 36, 30, 72, 720. So, multiply by 20, we get 720. And then another 2 is 36, so 22 it should be. Let's double check that. Just good brain exercise to try and guess it. All right, so 22. But obviously, you'd want to verify on the day of the test. So even when you're practicing. Okay, so we got 22 now. This is pretty cool. So look at this, right? I have I have height and base. I have height, but I don't know the base. But I can use this information to solve for the base, meaning KS. Now, it's not what we want. We want KT, but this is a good starting point. You'll see why in a second. So to get KS, let's do that in brown and let's call it W. Okay. So now we're going to do a nice little proportion. Height over base of the big triangle. Height over base of the big triangle equals height over base of the little triangle, because they are proportionate triangles, so we can set up this proportion, right? Equals height over base. And now we have a beautiful proportion. Now we can cross multiply and solve. Or you can see that to get from 72 to 24, we divide by 3. So 22 to W, we divide by 3, and we get 22 over W. Yeeks, I don't like that number. Wait, let me just make sure that's right. 22 times 72. Yeah, that's right. Okay. Well, we got a weird fraction, but it is what it is. So anyways, where did I write 22 over 30? 22. Oh, I didn't write it down. Okay, but W, as I mentioned, I haven't done this one before, so I'm doing this in real time. W is 22 over 3. That's a messy number, but that's not what we want. We want X. Okay, how do we get X? Well, I know this entire side is 22, right? And and this piece right here is 22 over 3. So if I do 22 minus 22 over 3, I'm going to have my answer, right? Take the difference. So this is 22 over 1 minus 22 over 3. We need common denominators. Multiply top and bottom by 3, and we get 66 over 3. Last but not least, 66 minus 22 is 44 over 3. And that is how you do it, 44 over 3. Oh, wait. Did I make a mistake? 24, not 22, somebody says? Hold on. LK, the length of LK. Wait, let me know if I made a mistake. Oh, somebody says, oh, XYZ. Hey, bro, I'm planning to give SAT to I haven't started math yet. How should I get started? Just start studying for the October one. Don't stress it out too much. You get more chance, but I intend to hit. How would I start studying? Well, I mean, being here is a great first step. And you got to start with a practice test. You got to start with loads of practice. Find good practice resources. I just got the College Panda book, by the way. I really like it. It's got a lot of specific practice problems based on question types. I think it's great. The gentleman, I can't remember his name that writes it, but he's always done a really good job. I submitted this question as weird fraction. I understand. Just wanted the review. Am I correct, Cole? Okay, good. Just making sure. Yeah. So anyways, I got 44/3. Just wanted to make sure because I don't see the answer here, but yeah. Okay. So this one does have the answer, so I'll be able to check. Here we go. This might be the last one that was, no, there's one more. According to a set of standards, a certain type of substance can contain that percent of phosphorus by mass. If a sample of the substance has a mass of this, oh, well, this is just literally taking a percentage of this. Okay, so we're taking 0.001% of 140. So when we do that, we multiply by 140. But first, we have to convert the percentage into its decimal equivalent. We do that by dividing by 100 or moving the decimal over 2 spots, one or the other, not both. But I'm going to leave it like this so it just doesn't look so crazy. But this is the easiest way. You take that percent, you divide it by 100, now it's converted to its decimal equivalent, then you multiply by the quantity. So we'll do this in Desmos. 0.001 divided by 100 times 140, and there's our answer, 0.0014. And 0.0014 is correct. So I don't know if the person who submitted this problem is here. Maybe it was Cole, but let me know if that cleared up your question or what you were asking about. Okay, what is the lag? It says 700 grammar, but a couple careless mistakes on the SAT got me a 600. I did worse on the easy problems of the math and better on the harder ones. Well, that's a good sign because that probably means you fell for a lot of traps. You weren't reading carefully. You maybe made some computation errors, but those things should be easy to clear up. But if you got some of the harder ones, that means your conceptual understanding, I assume, is probably pretty strong. So that's good news. Let's see. What else do we got here? XYZ. Man, I'm an international student, so I don't know much input on what's out there. I mean, I know math, but I just need to accustom myself to the format. So should I start learning? Well, all right. I don't know if you saw. I would start with the concept. So usually what I recommend, some people take me up on this, some people don't. But I'm like, hey, especially if you're going to work with us, the first thing is to start it with our free resources. But that's not just because they're free. It makes the most sense from a tactical perspective. Like if you start with the critical concept overview, you're going to start to fill in the gaps. There's also the formulas video here. I'm going to send that to SAT critical formulas video. So important. So if you also watch this video as well, you're going to have all the pieces to the puzzle right off the bat, right? Then you can dive in right after this. This isn't much time. There's like 2.5 hours, maybe like 4 or 5 hours if you're really taking notes, asking questions, etc. But once you get to that good spot where you kind of know the basics. Oh, I also have a really good Desmos hacks video. Not this one, but this one. I would also recommend this one as well. Once you get through all of this material, then you can start with your practice test and really experiment and play around with using these formulas. And then your first one, you might be like, oh man, I should have used this here, that there, blah, blah, blah. And then start to refine your process. Then you can also, another video that's very important. Once you start getting through the practice test is watch this, okay? Marathon. So I made this video to have an all-inclusive all-in-one video to review all the math portions of the practice. I streamed for like 4 hours. It was insane. I did this for the last August SAT. So you can check that out. So then you can take the practice test and to see what you did wrong, see if you can figure out the questions that you answered incorrectly and why you got them wrong. But then you can watch me do it in real time. So you can see my thought process, the way that I'm positioning myself to set up and solve each problem in the most time-efficient manner, and then adopt and learn from that protocol. So that would be my top-down advice, XYZ learning, on how to approach this, or XYZ dimension, excuse me. Oh, no worries, Cole. Can't use the percent on Desmos. Yeah, you can actually. Good point. So the other thing we could have done, it's a very good point. We could have said 0.01% of 140. Yeah, I forgot about that. Great tip from Sabo. Great job. Stockfish, hello, I didn't realize there was another J.E.D.I program. Will there be? Yes, there will be. And we're going to reformat and make it way more convenient and accessible for everybody for the next go-around for November. It's going to be awesome. How important do you think the unit circle is for the SAT? I don't think it's that important. I think it's cool if you know it. I think you can utilize it in certain ways, and I do talk about it in my concept Bible, but I think you can totally do great without having it memorized or anything like that. Just to have a general understanding is all right, just in terms of what the signs are going to be in different quadrants of like different coterminal angles, but especially with Desmos, I don't think it's that critical. All right, check it out. You're the hey, thank you, my friend. Are you gonna make a Of course, I'm gonna make a predictions video. It's coming out later this week. Thank you so much. Stockfish says you are welcome. Okay, let's keep it going. We got a couple more problems. Ooh, love that somebody submitted this. This is a mixture problem. I definitely think this is gonna show up on the October. So let's check it out. How many liters of a 25% saline solution must be added to 3% of a 10% saline solution to get 15% saline solution? All right. So I'm going to start with the mixture problem as follows. X, Y. X is my amount of 25%. Y, actually, they're telling us what Y is, so I don't need a Y here. That's my 3 liters of Y, of my 10% solution to get a 15% solution. Now, watch how I'm going to do this, right? I want an equation that connects everything. So we've got 25% of this solution, which I don't know what the quantity is, but 25% of that's telling me the amount of saline in it, plus my 10% solution, which I know the quantity, which is 3, okay? So that's giving me the amount of saline in the 10% solution, which is going to be 0.3, whatever the unit is, doesn't say, is equal to, hopefully, a 0.15% saline solution. So 0.15. And what's the final quantity? Well, I'm adding X liters of that or whatever and 3 liters of that one. So it's going to be X plus 3. And now I got an equation. Now I'm ready to solve. That's it. Now, if I did initially say Y here, that would have been fine. It would have been X plus Y. This would have been Y. But then later on, it would have been like, oh yeah, Y is equal to 3. You just sub it in, right? So anyways, that's it. So now we're going to distribute. We get 0.25. I mean, you can put this into Desmos too, but I think it's faster to do by hand. Equals 0.15x plus 0.45. Subtract 0.3 from both sides. That's 0.15. Subtract 0.15x from both sides. 0.25 minus 0.15 is 0.1x. Divide both sides by 0.1. And x is equal to 1.5 liters. Okay. Yep. And the answer is 1.5. Does that make sense, guys? So that you never get... Okay. Let me see what people are saying. Hold on one second. Louisa, can you come grab Kazi? He's struggling a little bit. Okay. So we've got all right, let me answer these questions. So I struggle with clinical depression. Oh, man, I'm sorry to hear that. Struggle with clinical depression for the last 4 years and it hasn't plateaued yet. So I get tired really easily and it demotivates me to give up, but I don't want to hate myself for it later on. I'm really sorry to hear that. I don't know if you work out or exercise regularly. I do know that that helps me tremendously, just kind of keep my energy levels up and keep my mood elevated and high. Even if I miss a couple days, I start to feel down. So I don't know if that's helpful for you, but man, working out is like, I don't know, it's like air to me. I have to do it. Oh, I like to do it every day. Helps my sleep, helps everything. So that might be something to explore, XYZ dimension. Okay. Let's see. Could you explain this one more time? Why 0.15 is multiplied by x plus... Yeah, sure. So check this out, right? Look at my equation. I've got liters of the solution times the percent of saline. So percent of saline times the liters gives me the amount of saline. Over here, I have percent of saline times the amount of solution. So you see we have this same kind of setup. Percent times liters. Percent times liters equals... percent that we're vying for, which is 15% or 0.15, times the total amount of liters, which is x plus 3. So you almost see like a bit of similarity or symmetry on the two sides. It's like, hey, we've got the same thing every time we're getting the amount of saline, and that's why all the quantities are equal. This is the saline in one piece plus the saline in another piece equals the saline in the total. Makes sense, right? That's why. So I hope that makes sense. You need parentheses as you're plugging a quantity. Did I not have parentheses? Why would it not be... somebody says, why would it not be 0.25x plus 3? Well, yeah, 0.3 you mean. You could say 0.25x plus plus 0.3. But again, 3, it shouldn't be 3. That's the amount of liters of the solution, not the amount of saline, right? You can't just say like amount of saline equals amount of plus the amount of liters equals the total amount of saline. Like that doesn't make sense. It's got to be saline plus saline equals total saline. Hence, we need that percentage. So I hope that makes sense. All right, here we go. We got a couple more problems here. Let's blot out the answer so we have some room. Okay, here we go. Total distance in meter traveled by an object in straight line can be modeled by a quadratic. I remember this problem. This is an old SAT problem. I'll do it though, but it's from the old version. So, and by the way, guys, if you are liking what you're seeing, make sure to click that like button. I'd really appreciate it. Everybody on the stream, I can't tell you how much your support and you joining along means to me. Plus, I can tell you that you guys are obviously dedicated and devoted, and it will pay dividends this Saturday. So, major props to you. But if you guys could give a couple likes here and there to push the video in the algorithm, we would very much appreciate it. Thank you so much. Okay, Cole says, oh, sorry, I was replying to the question. Cole says, never mind what I said above. I get it now. Thanks. You're very welcome. Doesn't it also work if you multiply all the percentages by 100 and leave them as nice whole numbers? Yeah, I mean, yeah. It would work. Why? Do you say that because you just don't like using the decimals? But yeah, you can multiply both sides of an equation anytime by the same, by a number, and it will maintain the integrity of the equation. So yes, you can do that. Okay, so coming back to this, we got a quadratic function, which is defined in terms of t, where t is the time, blah, blah, blah. And then we got a couple coordinates here. This is interesting, right? And I know they said t. I don't care. I'm going to do it as x and y because it's just way easier. So when t or x is 10, the total distance or y value is 50. When t is 20, the total distance is 200. So now I got a couple coordinates. That's really nice. If the object is a distance of 0 when t is 0, we got a third coordinate. Then what is the total distance traveled? Okay. So basically, we want to get the quadratic model from this information and then plug in 30 and solve. Okay. So let's check this out. Now, where I'm going with this is I'm immediately going to my standard formula for any quadratic, which is ax squared plus bx plus c. Now, the fact that we have 0, plugging in 0 gives us 0, right? If I plugged in 0 for x and we get 0 for y, tells me that c has to be 0, right? Otherwise, it'd be 0 equals 0 plus c, and it wouldn't work unless c is 0. So that's great. I already know that c is 0. I can just remove that. Now I need to know what a and b are. Well, those are two unknowns, and I have two coordinates. That's more than enough to solve. Let's plug and chug and create a system of equations. So when x is 10, y is 50. So 50 equals 10 squared, which is 100. Plus 10, which is x times b, is 10b. Second one is plug in 220. 200 for y, 20 for x. 200 equals 20 squared, which is 400a, plus 20b. All right, great. Now we're going to solve the system just like we would any other system. I'm going to multiply the bottom by -2 to cancel out the b's. Boop, boop, and boop. So we get -20b, we get -200a, and we get -100. Let's add them together. Goodbye. 400 minus 200 is 200a, equals 200 minus 100, which is 100. Divide by 200, a is equal to 1/2. Great. Now we need to solve for b. Let's plug and chug into any of these equations. Let's plug it in right here. So 1/2 of 20 would be 10. So 200 equals 400a plus 10. Wait, what? Oh, what am I doing? I plugged in for b. That doesn't make sense. Sorry. It's like, that's going to be a really weird number. This is a, my bad. So then 200 equals half of 400, which is 200, plus 20b. These are going to cancel out to be 0. 0 equals 20b, which means b is 0. So we got a very nice, easy equation. Goodbye b. A is 1/2. And there we go. Y equals 1/2 x squared. Now, we need to plug in 30 for, they said t, but we called it x. Plug in 30 for x. 30 squared is 900. Half of 900 is 450. 450 is the winner. All right, guys, I went through that a little fast. Let me know if that made sense, and that is indeed the right answer, 450. Nair says, thanks for the motivation. Awesome. Yeah, I find decimals a little daunting. Sure, no worries. You can get rid of them as you mentioned, or you can clear fractions and equations like that too. Do you think it's a good idea to give practice tests from sources like Princeton Review, Barron, and Kaplan? Yeah, so yes, some of the third-party tests are quite good. Let me give you my recommendations. Obviously, we have up top here, right? You can see over here. That's my recommendation, and that's the brand that I've partnered with and that I've made my own video explanations for. It's SAT Crash Course. So you can go there. You can use the code SCALAR for a 20% off discount. I think those are awesome, awesome tests. I actually have seen the print and review tests, and I think they're fine. I actually think they're all right. So I don't think those are a bad route. If you guys are familiar with Super Tutor TV, she also has a platform with practice tests that I think are quite good as well. I also know of another company called ScoreSmart, which is also good. As I mentioned, College Panda is a reliable source. You got a lot of options. If I did not mention a company, then maybe be a little cautious. Like, I haven't looked at Kaplan stuff yet. I will, but I haven't looked at it yet. I don't know. I can't speak on that. And normally I wouldn't even look at the Princeton Review stuff because I know all these other companies and I know the people behind them and I know they really, really care and they're trying their best to make really high quality stuff. But I had a student that had purchased the Princeton Review material, so I did have a chance to look at it and I thought it was fine. So I think actually they did a good job. Sometimes my issue with Princeton Review is it's a big box corporation. They're not like, I don't know, it's just a different approach than my or other of these like more boutique firms that we're teachers at the end of the day. We love what we do. We love helping people. We love working with students. And it's just a different mentality, different mindset, different approach. So I'm a little wary, but like I said, I looked at their tests. I think they're fine. Okay, guys, do not do... Callum, Ralph, you tried... Okay, yeah, I know that company. I'm not going to say anything. Stockfish. He did that in order to cancel out a specific variable when he noticed that 10 times 2 is 20. He multiplied by a negative so that when he adds the two equations together, the variable entirely cancels. Right. Oh, yeah, if you guys were wondering why I did that. How good is SAT Suite? I haven't seen SAT Suite. I don't know. Let me know what you guys think. I'll definitely check it out and review it. Okay. Last one. Here we go, guys. Almost out of time. In the given equation, and thank you so much for the likes, guys. Really appreciate it. If in the given equation, P is a positive constant, the sum to the solutions is 20. Guys, I need to know sum of solutions. Oh, wait. Never mind. No, this isn't a quadratic. Never mind. No negative B over A. Sorry. Okay. The sum of solutions to the equation. This is just a big polynomial function set equal to 0. Is equal to 20 over 3. What is the value of P? So what we need to do is we need to find all the solutions. Now, when it's in this nice factored form, we're just trying to figure out what every value that we need to get to 0. So here, so we need 3x plus P to get to 0. We can solve for x. 3x equals negative P. X equals negative P over 3, okay? So that's my solution there. What about here? If I factor out of 5, it's x squared minus 9, right? I can factor this more, set it equal to 0. But we know that my two solutions are going to be 3 and negative 3. And then over here, what's my solution? This one's a little harder, right? I can factor out a 2, but that only helps so much. I still don't know what P is. Oh, sorry, that's supposed to be 8x. I still don't know what P is, and we're kind of at a standstill here. But what I can do is I can run it through the quadratic formula. Again, one of the formulas that should be in your toolkit. So my quadratic formula, you get the solutions when it's set equal to 0, would be negative b, which is 8, plus or minus square root of b squared, which is 8 squared, negative 8 squared, which is 64, minus 4. A is 1. C is 3p. All over 2a. My a is 1. Okay. All right, guys, now we can create an equation. We're adding all the solutions. So we got the sum of the solutions, which is negative P over 3 plus negative 3. Those are going to cancel out. And then plus 8 plus rad 64 minus 12p, right? 4 times 3p is 12p over 2 plus 8. Let me move this over. Again, I'm just adding up all the solutions. 8 minus radical 64 minus 12p over 2. Okay, and this is equal to 20/3. So now as we add all these up, those are already gone. When I add these two together, look, this is positive of the radical, negative of the same radical. They're going to cancel out. That's beautiful. So then I have 8 plus 8, which is 16 over 2. So now I have negative p over 3 plus 16 over 2, which is, of course, just 8. Is equal to 20 over 3. And now we're going to keep it going. We're going to minus 8. Negative p over 3 equals 20 over 3 minus 8. And 8, I'm going to get a common denominator, multiply top and bottom by 3. If I put it over 1, we get 24 over 1. 20 minus 24, let's see a 3. 20 minus 24 is negative 4 over 3 equals negative p over 3, which means p, therefore, to make this equivalent, would have to equal 4. Okay, let's check the answers, and we're going to wrap it up for today. The correct answer is 4. Boom, done. Okay, negative b over a for the third. Yeah, oh, so smart. You could have done negative b over a for the third. Dang it. Should have caught that. Should have caught that. Who said that? Nair. Very smart. Yeah, you could have used negative b over a for that last one instead of using the quadratic. That was bad. I've done that before when I've looked at this problem in previous videos. Very good. Yeah, I love. If you're talking about SAT Panda, if you mean College Panda, love College Panda. Love College Panda. Just got the book myself, and I think the questions are phenomenal. Yeah. And some good reading questions. Oh, Cole's also seen SAT Panda. Yeah, awesome. All right, guys. That's it for today. That's the finale. That's the class. We got Dan coming back on Wednesday, so make sure to come back for that. But make sure to stick around to this channel and subscribe because we got predictions videos coming out. I'm going to do another big video. I'm not going to tell you what yet, but it's going to be out before the end of the week. So make sure to check back in, watch those other videos that I mentioned, watch the SAT Math Marathon, and that is it. Ladies and gentlemen, thank you guys so much for joining, and I will see you in the next video. Take it easy.